Proteins are among the most versatile and complex molecules produced by living organisms. Their functions range from simple structural building blocks to regulators of highly complex processes such as cell division. Assembled one amino acid at a time, proteins coil into a wide variety of shapes. It's easier to see the underlying structure if we create a tubular trace along the backbone. By coloring the tube from start to finish, you can see that this molecule, the acetylcholinesterase enzyme, is composed of two large domains. The European Synchrotron radiation facility in Grenoble produces some of the brightest X-ray beams on Earth by accelerating electrons around a vast storage ring. By studying how X-rays are scattered by tiny protein crystals, pictures of molecules can be reconstructed in atomic detail. There is a price to be paid for using intense radiation. Protein crystals rapidly disintegrate in the beam. Until recently, damage was thought to occur in a random, haphazard fashion. In the large, there is very little apparent change in the backbone atoms. The center of chemical activity, the active site, is a region buried deep between the domains. Disulfide bonds help to stabilize the backbone by tying together nearby strands. First, let's examine this bond on the exterior of the protein. Here we see the actual change in electron density during the course of the experiment. This disulfide bond disintegrates within the first few minutes of exposure. Now let's examine a bond deeper inside the protein. Surprisingly, this bond isn't affected. This disulfide remains intact for the duration of the experiment. The B factor for an atom gives an indication of possible movement or disorder. When the change in B factor during the experiment is examined, 3 amino acids stand out: cysteines, which engage in disulfide bonds, and the negatively charged aspartic and glutamic acids. Here we have color-coded side chains in the active site. Red and yellow indicate loss of order. Clearly, radiation damage is a highly discriminating process.